Hey guys, welcome back to the channel. I'm your host Mohin. Today we are kicking off a brand new portfolio project where we analyze a real world online retail dataset using Python. If you are looking to build a strong data science portfolio, this is a perfect project for you. We are going to take real messy data and clean it and find future sales and its trends and visualize the results. So in the part 1 of the video, let me give you the overview of the things. This is the task which we are going to perform in this video: an online retail exploratory of data analysis with Python. This is the case study which I have gone through, and you can also refer it back, and the objectives, project objectives, and this is the data set which we are going to look into. If you open the data set, it is a CSV file of this format. As you can see, it has all the data separated with commas, and it's a very long data file. Now the thing what we are going to do is in this part is we are going to check the first 4 tasks: load the dataset into pandas data frame, perform cleaning, explore basic stats, and perform data visualizations. So let's kick off with the pandas data frame. As you can see, I have already loaded the data file into the Google Colab. In this project, I am using Google Colab as a source to run the Python file and analyze the trends. So as our task 1 says, loading and inspecting the data. Here I am using pandas, which is panel data's library, and also numerical Python library, pandas to read the data file, and numpy to perform statistical operations, which is provided in the task 2. So I'm defining a data frame with df and reading the data file, which is our CSV data file named as .csv. If you can open this data file and see the encoding of it, it contains Latin 1 encoding, so I have optionally provided it with Latin encoding, and this is optional, not a compulsion. You can check. Then if you open the data file is successfully loaded. As you can see, I am running the project. As you can see, the data frame is successfully loaded the online CSV file into the data frame df. Now if you can see, when I load the head, it gives us about the first 5 rows in the data. These are our columns: invoice number, stock code, description, quality, invoice date, unit price, customer ID, and country. These are the first 5 columns of the data frame. So if I think what is the total number of rows and columns in this data frame, so I can give the function as data frame dot shape or df dot shape. If you run this code, it provides us with 542,000 rows and 8 columns. As you can see, we have 8 columns and the number of rows would be 542. Okay. So to get an info about the characteristics of the data types and all the type of the thing, so I am using the function df.info. After loading the function, as you can see, it gives the memory usage and the operators associated, and this shows the info about the data with respect to the file. Now the second task, the most important task, what we get from this file is like there may be some kind of redundant data, some kind of cleaning operations has to be performed on it, and there could be missing values. So we have to consider these 3 factors mainly for any data set and proceed with it. So in the step 2, as you can see, I have uh, perform the operations of data cleaning. The first operation which I have performed is I want to know the missing values. How do you check the missing values? The missing values are you checked using the function is null. Is null provides the missing value, but is null function just could not just provides the first missing value in the column. So we need sum of all the missing values with respect to one each particular column. So as you can see, I have printed the function and then I have printed is null dot sum to check sum of all the missing values in one particular column. As you can see, we have 1400 missing columns in description, which might not be a big issue for us, but we need to clear it. But customer ID, we can see 135,000 135k missing values, so this could be a major issue for us. So I think we need to clean it. We have to clean it. I'm sorry on that. So for cleaning the customer ID, mainly I have used fill the unknown things with the unknown columns with the word unknown. So wherever there is I'm using the function fill LNA to fill the missing values, and I'm replacing all the empty boxes with the word unknown in place equals to true, and I am removing all the columns. If you can see here, I am removing all the columns which has empty description. These both commands have successfully run. Now if you run my data frame, as you can see, you may see this data frame does not contain any kind of missing values. Let's look at 0 to 5 and the last 5 columns. It does not contain any missing values from the description, nor it does contains any customer ID as missing. Now the main thing what we have to do is also drop duplicates. So the function would be data frame dot duplicates. This function is also ran successfully into the data frame. Now our data frame contains that data frame which is redundant from inconsistent or missing values, null values, and also duplicates. Now as you can see, we have loaded the data frame successfully. We have performed all the handling functions such as missing values, redundant values, and also duplicates. And now here we need to perform basic statisticals of data, including central tendency and dispersion. Before providing the statistics, if you can closely see the data, there is a column known as unit price and quantity. We don't have the gross price or the total price. It's better to calculate pre with dummy column, giving it a name of total price or gross price, multiplying the quantity and unit price and getting the total value of it. So that's the thing. Before going to the next part, I have done the calculation of gross multiplied quantity and unit price and created a column as gross value. Okay, now if you can see in the data set, we have quantity, unit price, and then a gross as a column, which is the total sales. Now statistical summary. Now I have gone into the statistical summary of this data set, where generally for statistical summary we use the function describe. So I have performed the same operation. Describe function gives us about the number of rows in quantity. Number of rows are same and we don't have any kind of empty cells. I have removed it, so the number of rows are similar. The mean with respect to each value and standard deviation of it, minimum value, maximum value, what is the median, and 25% and 75% is shown. For central tendency, we mostly calculate mean, median, and mode. I have also shown the median with respect to numeric values only, just to show that this this thing is matched. Look at them. 50% quantity, 50% is 3, then unit price is 2.08, and gross is 9.0. These values are true and are correct. Then now I am here to focus mostly on the measures of central tendency, as I have written here. Yeah, everything is run successfully. Now measures of central tendency. Now I am calculating the mean, median, and the mode values. Now for calculating the mean, you can use direct the function dot mean for on numerical operations. So that's the reason. So I have described a variable mean values, and given performed the mean operation on the data frame where numeric is only true. Okay, and then I have calculated the median values. I have created the variable and given the function dot median for on upon the numeric values only, not the description or categorical values of the data set. Calculation of mode, where I have used n, where only the first mode occurrence of the mode, what are the values that could be uh, provided by the data frame. I have also calculated the maximum value and minimum value to calculate the range of the data set. What is the lower limit and what is the upper limit of the data range? That's the range basically. Then I have also uh, calculated the variance, which is the spread across the mean, how the values are spread across the mean, and it's the standard deviation. I was keen to observe about the quartiles such as Q1 and Q3, which is 25% quartile and 75% quartile, and interquartile range. So with pandas, I have created another variable stats, a summary stats, because I want to display all these values using these pandas. Okay, so summary stats I have given. I have created a data frame where I have given the name of the data frames: mean, median, mode, range, variance, standard deviation, and interquartile range. And the variables which I have hold the value in it, I have associated these variables here and displayed this data frame. Let me run this for you. As you can see, for quantity, unit price, and gross, three are the categories in the data set for which I have calculated mean, median, mode, range, variance, standard deviation, and IQR. These are the values. I have done the same thing, but in this calculation what I have done is I have calculated the mode that there could be a there could be a thing where the values could be more than one for the mode, such that a data frame may contain bimodal or multimodal one. So I have also done this thing to get multimodal things, well defining the mode and also iterating it with if condition and and returning it, and if there is nothing then return mode of 0. So as you can see, and I have cross checked it, the values being the same with respect to mode in all three: 1, 1.25, and 15, means there is no more than one mode with respect to this data set. Let me show you 1, 1.25, and 15 in the earlier one, where I have considered only one mode could be the in the data frame. When I have considered the option of more than one mode, the results are same. So this is the thing which I have performed here with respect to this code. Now I normally in this CSV data types, the date is in date format, but just to clear out the confusion on the first, which would be later an error, I created invoice date and changed its variable, I mean the type of the date, as date time format, to minimize any errors while I perform operations on it. look, I have converted the invoice date where it is converted to date time format of invoice date variable, where the format is ddmmyyyy. Day starts first, so that's the reason dd it starts first, and if there are any errors I have coheres it. So by checking at the data types of the variables, as you can see, this invoice date has been changed to date and time format. Now with the other operations for the data set, what we have seen is perform data visualization to gain insights into the dataset and generate appropriate plots. Okay, to perform these kind of things, I thought like the normal line trend what we used to do the analysis on. So I have concatenated the month and the year to perform a line graph with respect to it. As you can see, making a new column for the month and year within the invoice date, I have first taken the part of it with the copy format, and uh, uh, the thing why I have done this is to provide a line graph or visualization thing in order to describe the line trend or the forecast the sale trends with respect to month and year. That is the reason I have taken month and year part from the actual invoice. Let me run for you. Yeah. Now here comes the part of uh, visualization. So now in this portfolio analysis, I am using matplotlib, which is a very functional and handy library for visualizations. So I am importing the matplot library pyplot as plt and numerical python. Numerical python is to perform numpy is numerical python is to perform any kind of statistical operations on the dataset. Now here I am creating the line chart with respect to gross sales by month. As you can see, this is my line chart prepared with respect to year and month year analysis. What are my gross sales? The sales in thousands. As you can see the code, first I have first given month data and group by month year. I have grouped month and year, and sum the number of sales in that particular month of the particular year, and then after the month data I have used the function of reset index. Reset index is used when an operation is performed on the data, and this operations is associated with the data. Reset index removes those operation and just the sufficient just takes the output. So here you can see the month data as a type string. I have used in order not to make complicated. Matplot understands the data is better understanding the dates not as date time format but as string, so that is the reason I have converted it as type string to avoid any kind of complexity and errors. Then I have plotted the axis with 10 and 5. 10 10 and 5. Okay, now I have automated the labelings figure axis as 1 2 3 4 5 boxes, and 10 this one. Yes, figure size of 10 and 5, which is subplots. As you can see these small squares. Now I have given a line style as dash and color as dodge blue and label it as gross. label it as gross. As you can see, the forecast analysis of this month and year with respect to the code. Gross by month, font size 16. This is all the title, the X label, the X axis, the Y axis, the grid style, and the box where I have written the gross as a my parameter. And with show function I am showing the graph. The next graph what I performed is the heat map. Now I am also using not just matplotlib, the cbon, which is cbon is generally used to perform advanced statistical visualizations on the dataset. So I have imported the cbon as sns, set up the same thing, fixed size as 10.5. Then I have developed a correlation matrix for numericals only. Then a diverging palette with cmap equals to true. And let me run you and show the data code with you. This data code gives the correlation matrix with respect to the quantity, unit price, gross, and the relationships among it on a scale from 0 to 1. The correlation is a kind of relation that shows the relationship between two quantities. uh, how are they related to each other? Is there any kind of positive relationship between the variables, or is there any kind of negative relationship between any two variables? So with plot.show I have displayed this matrix. You can check the code. This is a generic code which we use for the creating of heat creating of the heat map or correlation matrix. Thank you everyone.